Saxon Algebra 1, lesson 88. Students, it's a good one today. It's just pure algebra, super useful. We're going to put these skills to work many times in the future, and this builds really nicely on what we have been doing. We have been working on factoring quadratic expressions. I know, that sounds really fancy. Let me show you what I mean. We've been taking expressions written in this form, right, where A, B, and C are actual numbers, and we've learned how to factor them. We've learned how to break them down into two binomials that multiply together to get them back, right? And I've drawn you that picture where we're just going in a big circle, right? Let me give you an example with numbers. What if we have x squared minus 3x minus 10? And we know that there's a way of factoring. We call it factoring by inspection. There are two other kinds of factoring that we're going to get to later. And the way that we do that is we look for a pair of numbers that do two things. They multiply to C, this number at the end. They have to multiply to that. And two, they have to add to B, this number here in the middle, right? I don't know that we've talked about this A and B and C thing before, but that's a really nice way to write out these rules. They have to multiply to C and add to B. So this is what we've been doing. Again, I don't know if I've ever called it factoring by inspection, but that's what it is. And these are the rules we've been using all along. So, and we know we're gonna draw just a pair of binomials, and we know x is gonna go in the first place. So let's see, what are two numbers that multiply to 10? Well, besides 1 and 10, which are not gonna have a difference of 3, I can see that 5 and 2 would work, right? 5 times 2 is 10. We're gonna have to make, excuse me, I'm yawning. We're gonna have to make one of them negative, and so this helps us see, oh, it's gonna have to be -5 and +2, right? So we've been doing that, and that's familiar, right? That's familiar and easy. What we're going to do is one more step. We're going to, and I'm just going to show you rather than try to explain it in words. Let's do one. And then we will see. 88.1. I'm going to change it ever so slightly from what John's giving us in the book. And I'll explain why. But if you look at this in the example 88.1, you'll see this is written slightly differently. Okay, that looks fine. That's familiar. That looks just like this. We're fine. We can do it. The only thing that's different is we're now going to deal with an equation where the right side is set to 0. And sometimes we have to do that ourselves. Sometimes John will do it for us. But we always want to set the right side of the equation to 0. This, remember, is when we're writing a 0 and we want to make sure people think it's not an O, we put the slash through it. Okay, so this is always set to 0. Now, what we do is so that's step number 1 in these problems, is we always set the right side to 0. Step 2, factor as usual. So we do this, equals 0. Just that we just copy in. Look, it got really squished, sorry. X and X. We use our same factoring by inspection rules. That hasn't changed. Let's see, it could be 9 and 2, but I can't get a difference of 3 with 9 and 2. 1 and 18, no, not going to work that way. How about 3 and 6? Aha, there we've got it, right? 3 and 6, one has to be positive, one has to be negative. And I can see by this, I want the 6 to be negative and the 3 to be positive. That'll give me that minus 3 difference. Okay, so now we have that this quantity equals 0. Okay, now I'm going to introduce another new idea to you. And I'm going to copy this to the top of the next page. X, let's see, it's plus 3 and x minus 6. Remember that it doesn't matter which order these two binomials are written in, as long as the signs and the values are correct. The order doesn't matter of the two quantities. All right, now I'm going to introduce a new idea to you. It's called the zero product theorem. That sounds so hard, but it's a super easy idea. When you first learned how to multiply, back in the day, right? Remember that day? I remember so distinctly the day I first learned about multiplication. I was in 3rd grade, and we made these really cute multiplication charts, you know, where you start filling in all the numbers yourself, and we got to decorate them, and I made like a flower vine that went around mine, and I was really proud of that flower vine. Okay, one of the things we learned really early in our multiplication facts is that if you multiply anything times 0, the answer is 0, right? So I'm going to write that. Anything times 0 equals 0. That is true, right? So what that tells us is that if you're multiplying two things together and they equal 0, then one of those things has to be a 0, right? The zero product theorem allows us to say, at this point, either x plus 3 equals 0, because that's one of the things we're multiplying together, right? We're multiplying these two things together. So either the first one equals 0 or the second one equals 0. That's what the zero product theorem does for us, is it helps us say that either that one is 0 or that one is 0. And that is so helpful because now we have two simple little equations to solve. Subtract 3 from both sides, and that tells me that x in our problem is either -3 or, and here we'll do the same thing. We'll just do a quick little algebra. Cancel, cancel, I'll mark them both. X equals +6. This is the answer to our problem. And if we wanted to, we could take -3 and 6, plug it back into our original equation, and it would work out to be 0, okay? Let's see, so step 3, right? Step 1 is set the right side to 0. Step 2 is factor as usual using inspection. Step 3 is to use the zero product theorem, which is this. And the actual step is to use the zero product theorem to solve for x. Okay, let's do another one so you can get the hang of it a little bit more. Example 88.2. Let's see how many there are. 1, 2, 3, 4. Oh, John's feeling frisky. He gave us 4. Okay, 88.2. Let's see how John gives us this one. This one's slightly different. I want to do 88. Well, we'll do 88.2. John put them in this order for a reason. These are slightly different rules. He wants us to, when he says find the roots, That's the way he sometimes described these problems. That just means solve for x, which is what we did before. No, I don't want to do 88.2. I'm going to do 3. I'm going to skip 2 for a reason, and I'll come back to it. Find the values. Okay, that's another way of saying the same thing. So there are many ways for John to say solve it, but this also means solve for x. Okay, ready? X Our first step is to throw all the terms to the left side and set the right side equal to 0. So what we have to do is move this x squared over here. Now we could move all these guys over here and rewrite it, but I don't like that minus in front of that. That bothers me. So I would prefer to swim the x squared this way. And now we have x squared plus x minus 56 equals 0. That's our step 1. I wrote it out on the other page. I won't write it out again, but I'll identify it. Step 2 is to factor it by inspection just the way we know how. The only thing that's different is we just copy equals 0 and put that on the end. Okay, 56 I consider to be the hardest multiplication fact to memorize. It's 7 times 8. And one of those numbers is going to have to be negative, isn't it? Because we need negative. The difference is positive 1, so that means we want the bigger number to be the plus, the smaller number to be the minus. Now they multiply to that, and they add to that. Take your time and check that to make sure that you really have satisfied all of the requirements of that factoring by inspection. Okay, some of them are really easy. Other ones, oh, it's really easy to get messed up in the pluses and minuses. Third step, use the zero product theorem to solve. And the way that we do that is we say, okay, these two things are being multiplied together. They equal 0. That means one of these has to be 0. So either x plus 8 equals 0, or, and you know, I like to just write the word or right there to remind us of what this is all about. X minus 7 equals 0. Now we solve, and fairly soon you'll be able to solve these without showing the step there. You'll see, oh, you just take the opposite sign. But for now, I'm going to go ahead and write it out so you can see very clearly. X equals 7. And there are the two solutions to this quadratic equation. Are they right? Yes. The other ones were right as well. This. Okay. Let's try number 4. We're going to go back and do that other one in a minute. I just think John should have saved that one for the end because it's weird. Okay, now this time he just tells us straight to solve. I appreciate that. That's the most direct way of asking us to do this problem. And this is what he's got for us. 3x squared. Now there's trouble right there. I don't want a 3 in front of my x squared. That gives me trouble. So let me write the rest of the problem and we'll figure out what to do about it. Minus 6x equals 9. Okay, well I know that for my first step, I need to push everything to the left side and set the right side to 0. So I'm going to do that. This will come across, it'll become minus 9. Remember that if we want a number or letter to change sides, then we need to make it change signs. So if it's positive 9 on the right, then I make it negative 9 on the left, and that side's 0. Okay, so that's my step 1, but now we're going to add a new little wrinkle to step 1. We also have to get our x squared with no number. It's technically got a 1 in front of it, right? Because we can ignore the 1. But we don't want any 3 there. So we divide away okay, we're going to divide by any, I'll write by, that helps this make sense. Divide by any a value. This is the a value, right? Because it's ax squared plus bx plus c equals 0, right? That's called the standard form. And we use these a, b, and c just to help us write rules about them. So if a, the letter in front of the x squared, is not an invisible 1, then we need to divide it away. And at this point, we can trust John to make sure that the numbers will work out even. You can see with a glance, it's going to be fine. Later, we'll deal with this with other ways, but for now, just trust John that if you divide away by that a term, the other numbers will come out fine. The 3 cancel. Now we have x squared. This becomes 6 over 3 minus 2x, and minus 9 over 3 is minus 3 equals 0. This really bothered me when I first learned how to do this. I thought that having a 0 over here, you divide it by 3 and it doesn't change. I thought that would somehow throw the equations out of balance. It doesn't. It's fine. So don't worry about that. We're good to go. Number 2, factor by inspection just like we used to. The only difference is we just keep the equal 0 at the end. Okay, x, let's see, how about minus 3 and plus 1, right? Beautiful. And now we are ready to set these up. Either, if these two things multiply to 0, that means either x minus 3 equals 0 or x plus 1 equals 0. This time I did not write the word or in between. I just pushed them apart a little bit so that anyone looking at this can see I'm exploring 2 alternatives. Now, again, if you feel comfortable with the algebra, we can use the rule that when we change sides, we change signs. So we want to move this 3 over, so we can say x equals positive 3. As we move it from left to right, it has to go from negative to positive. This is one solution. And here, same thing, we want to move this across. As it changes sides, it needs to change signs, so the positive becomes a minus. You can swim it as a normal fish, and you will get the very same answers. This is the format I want you to go ahead with. If you'd like to write or in the middle because that makes you feel more comfortable, that's fine. But I prefer to just see them with a little separation in between so that I can see, oh, you considered 2 separate scenarios. And then I like to see the 2 solutions boxed separately. Like so. This isn't wrong, but I just like to see it a little bit better like that, okay? Beautiful. Those are the 3 problems that follow this very strong pattern that we're going to do over and over again of solving a quadratic equation. We're no longer, let me go back to the beginning. We're no longer just factoring, right? That's all we did before. We just did that much, right? We'd see that and we'd get that and that would be the answer. Now by putting an equals 0 at the end of it, we're able to actually solve it all the way through, right? Here's my answer here. This was right by the, oh yeah, I did smiley face it, okay. Now we can actually solve them. Just by writing equals 0, it gives us a couple more steps to finish the problem. Okay, we're gonna go back and do number 2. It's not more difficult than the other ones, it just looks a little different. So I wanted to do those 3 in a row because the factoring on those is exactly the same. We factor by inspection. On this number 2 problem, it's gonna look a little different. Let's see what John tells us. He says find the roots of. I think we already talked about that expression. Yeah, find the roots. That just means solve for x. It means the same thing. It just sounds fancy. 88.2. Find the roots of minus 25 equals minus 4x squared. Oh, good Lord. That doesn't look right. We know we're going to have to do some swimming around, but we know there's no way that we can make this look like that. There aren't enough terms. So that's fine. We're not going to worry about this right now. What we are going to worry about is getting everything on one side. And I see the 4x squared. I don't like that minus sign. So that tells me, let's bring the 4x squared this way. That cancels. So now we have 4x squared minus 25 equals 0. All right, so that's our step one. We cleaned it up, we moved it. We have a number in front of here, but don't panic. We're not going to divide that away. As you can see, it wouldn't work because 25 divided by 4 is not our friend. What we're going to do is we're going to factor using a different pattern, I would say. Okay, so we're not going to factor by inspection because that's not going to work. The way we've done it with this, that's not going to work this time. What I'm going to do is I'm going to remind you of a different factoring pattern that we studied, I think, before Christmas. We called it the difference of two squares. And we said that if you can identify that the first number is a perfect square, the second number is a perfect square, and there's a minus sign in between, we can factor it like this. Right? I'm going to write the name of it down here. Difference of two squares. This is the pattern that we're going to use to factor this equation because our usual factoring by inspection is not going to work. So this pattern will work because perfect square and perfect square. That's how I knew to do that. I knew something was up because there was no plain x term. And I knew that if I tried to divide both sides by 4, this wasn't going to work out. Those were my two signals that the usual way of factoring by inspection was not going to work. So now we're having to use a different factoring pattern. Spoilers, on other problems, we might have to use a third way of factoring, right? Maybe it's not the difference of two squares either. Maybe there are other ways to factor that we'll have to try to dig out of our memory banks. So it isn't always difference of two squares, but that's what this one is. So now we can see, all right, in our problem, A, the square root of this first term is going to be 2x, and B is going to be 5, right? Now we can just write this out. It's still going to be equal to 0. It's going to be 2x plus 5 and 2x minus 5. See how I used our factoring pattern? Just like we did these problems before, it's equal to 0. Okay, I'm going to take it up to the top of the next page. And I'm going to say, again, whether we put the 2x plus 5 quantity first or the 2x minus 5 quantity first, it doesn't matter. What matters is that we have one of each. Okay? In multiplication, order doesn't matter. So these quantities can be written in either order, whatever makes you happy. And I think, yeah, see, it looks like I went crazy, right? Because it should be minus and then plus, but I did plus and then minus. It's okay. It doesn't matter. You can memorize the formula with either one first. You can use it as you wrote it, or you can mix it up. So you get some latitude there. Now we're going to do the same thing. We're going to use the zero product theorem, which says that if two things are multiplied together and they equal 0, then one of them has to be 0. So either 2x plus 5 equals 0 or 2x minus 5 equals 0. And then we do the same thing. We both just keep working these with basic algebra to get the x by itself. So let's subtract the 5. Whoops. And we get 2x equals minus 5. And then we'll have to divide both sides by 2. And we get x equals minus 5 over 2. And then here we have to add 5. 2x equals positive 5. And then we'll divide by 2. And we'll get x equals, here, let's cross those out. X equals 5 over 2. Yay! These are the right answers. Okay? So, in the first three, we had the same factoring strategy. We used our factoring by inspection. In this last problem, we had a different factoring strategy. We had to factor using the difference of two squares. All right, so we have to be on the lookout. Most of the time, we'll use our basic factoring by inspection, but every once in a while, John will throw us a weird one that requires us to think, oh man, how are we gonna factor that? And that can be a little tricky, but it's good because it gives us a chance to practice all of our other factoring strategies. And I know you want to. Look, that is the end of week 23. We have 2 more weeks of homework before spring break. Well, before our midterm, and then spring break. So keep on top of your formulas. Make sure you understand what you're doing. And I'll see you for lesson 89 next time. Thank you.